Okay, so the good news about this chapter is it's all worksheets. And I know how you like worksheets. I will put my keys online so you can check your answers as you go. Okay? So we call this unit motion. We say it's rectilinear, where linear motion means you're moving back and forth or up and down. Okay? Most of our motion, like 90% of the motion that we deal with is going to be back and forth. So right to left, right to left. Okay? So instead of using the x-axis, we're going to call it the s-axis, and that is going to be the axis we're moving along. Okay? And t is going to denote time. Okay? So we will be graphing in 2 dimensions. Position versus time. We'll graph velocity over time. We'll graph acceleration over time. But we're only talking about a particle moving back and forth and back and forth. Okay. So we will talk about average velocity and we will talk about instantaneous velocity. In that assignment that I gave you last night, I asked you to think about what it meant to be the rate of change of position, okay? And you came up for me with the fact that velocity is going to be the derivative of position. If we're talking about change of position over time, okay, that relationship is a derivative. So when we talk about instantaneous velocity, we're talking about the rate at which a particle's position changes with time. Okay, so ds dt, it can be how we describe that, right? Change in s over change in time. Okay. So we are going to say that our velocity is the derivative of position. Okay? I know that you looked at that in that intro assignment, but I want you to have it written down in your notes somewhere. Don't feel like you have to write every single word that I have up here. Write down what you need to. For sure, this right here, that our velocity is the derivative of position. Okay? In physics, do you work with position, velocity, acceleration in terms of how they're related? Okay. So what's nice for you in calculus is you get to see all of the mathematics behind it and why they're related the way that they are. And we're going to have some shortcuts now that we know how to take derivatives.
Holocaust speaker assembly. They should be heading to 4th hour. Again, students are being released now from the assembly. Please welcome them into 4th hour. Thank you.
Welcome them. We need to welcome them. Okay. Okay, if I wanted to describe speed, how would I describe speed if we know velocity?
Speed is velocity without direction.
Excellent. So velocity could be positive or negative because we're talking about direction. So how do we describe something with taking off the positive and negative? Okay. Speed is going to be the absolute value of velocity. Okay.
Do you have like numbers on the screen sheets?
Yes. There's somewhere in there.
Do you mind if I look
I
at it?
don't mind at all. Did I give you the wrong file?
You must have. I don't have very many.
Interesting. And it's 4th hour, isn't it? Yeah. Okay. If our particle is moving right to left, then positive velocity, you told me, means that the particle is moving which way? To the right. When we move right on a number line, we're moving in the positive direction, right? We're getting bigger with our numbers. So it makes sense that our positive velocity is going to the right. Which means if we have negative velocity, that means we are moving to the left. We need to be able to look at an equation. We need to be able to look at a graph and be able to tell what it tells us about the position, velocity, and then eventually acceleration. Okay, which is why I asked you to read that graph on your homework. So throughout today, we're going to look at graphs for position versus time, velocity versus time, acceleration over time, and talk about what it tells us. So here is this. Our position is t cubed minus 6t squared. I would write that down. Our position, S of t, is t cubed minus 6t squared. Okay, so let's talk about what this means. I would maybe draw in this graph so we can talk about the different things. And I would say as long as you have this labeled as 6, you don't really need the other numbers, but just quickly draw in what that curve looks like. Okay, let's go ahead and read this graph. So we are at the s-axis, the t-axis at 0 and 6. So at time equals 0 and time equals 6, our position is 0. So we would say that our particle is at the origin. Okay. When our position is negative from 0 to 6, that means our particle is to the left of the origin. And when past 6, when our position is positive, we would be to the right of the origin. So we are to the left from 0 to 6, and we are to the right after 6. Now, I'm not describing the direction in which we are moving. I'm just saying our position relative to the origin is either to the left or to the right. Okay. Now, what would our derivative be, Colby?
The actual
Yeah, the actual derivative.
3t squared minus 12t.
Okay, so our derivative is 3t squared minus 12t. So that would be our velocity equation. Our velocity could be described as 3t squared minus 12t. Okay, and go ahead and sketch in this graph, being sure to label this as 4. You don't really need the other numbers. What is true about the velocity at time equals 0 and time equals 4? What was the value of our velocity? What's our y value?
0.
Okay, well instead of y, it's v, okay? So here, at time equals 0 and time equals 4, our velocity is 0. What did we say about velocity being 0? What's happening to our particle? It's not moving. So, okay, so at 0 and 4, our particle is not moving. Okay, well, it has to start somewhere, right? So it's not moving in the beginning. Why is it not moving at 4? What's happening at time is 4? we're changing directions. From 0 to 4, our particle is moving left. And from 4 past, our particle is moving right. So at 4, we're changing directions. Let's talk about how we know this. This is velocity, which means it's our derivative, correct? Our derivative is, our velocity is negative from 0 to 4, which means we're moving left. Our velocity is positive, which means we are moving right. Could we tell this information from the graph of position? From 0 to 4, our position is decreasing. And decreasing, we're referring to a description of the value of the derivative. So since our position is decreasing from 0 to 4, we knew that the velocity would be negative. From 4 on, our derivative would be positive because our position is increasing. So we would know that the velocity is positive from 4 to infinity because it's our derivative. So all that stuff we did with analyzing graphs, okay, that's all going to come into play here. Okay. If we wanted to talk about speed, don't feel like you need to draw this, but if we're going to talk about speed, we throw an absolute value on our velocity, which means any negative velocity becomes positive. Okay. And we'll talk about the concept of speeding up and slowing down here shortly. Now, let's go back to our velocity, 3t squared minus 12t. Okay, Chris, what would the derivative of this equal?
6t minus
Okay, 6t minus 12 would then describe our acceleration. Okay, acceleration, we decided, was the derivative of velocity. So acceleration we describe as the rate of change of velocity. So it's the rate of change of the rate of change. Okay, so our acceleration for this problem that we've been dealing with would be 6t minus 12, and we'll look at that here in a moment. Okay. Now, those of you who are in physics, I am going to need your help. Okay, we need to talk about the concept of speeding up versus slowing down. Ooh. Is it really just a matter of acceleration? Adam, you're shaking your head.
Well, it just depends on like what direction you're going, if you're speeding up or something.
Okay, so it depends on the direction of where you're going, if you're speeding up or slowing down. So acceleration is not the only factor. Acceleration could be positive or negative. Velocity could be positive or negative. So if I want to be speeding up and I have positive velocity, what needs to be true about my acceleration? It also needs to be positive. If I have negative velocity, if I want to speed up in the negative direction, then my acceleration would need to be negative, okay? So if you have acceleration and velocity that have the same sign, which means both acceleration and velocity are positive, both acceleration and velocity are negative, then we know that our particle is speeding up. Ooh, 2 E's. Okay, so if your car is in drive, that means you're going to go forward, right? And you step on the gas, you are accelerating and you have velocity going in the positive direction. Okay? Once you hit that brake, your velocity is still positive because you're in drive, but when you hit that brake, your acceleration is negative, therefore you slow down. Okay? Same thing can be true with if you're in reverse, right? Okay? So when velocity and acceleration are different signs, that is when our particle would be slowing down. Like I just described. If you're in drive, but you hit your brake, you have positive velocity but negative acceleration, so your car is going to slow down. You're like giving signs over here. Feels like it should be Friday, doesn't it?
Yes.
Yeah.
Is this only our first week back since spring break?
This is our second week back.
Oh.
Apparently it's been like the longest week of your life.
It
and
has.
It's been 2 weeks.
Oh my gosh.
Last week was like, this week was like,
Last week did go really fast.
Last week, this week has dragged forever.
And then,
Yeah.
and then next week will be quite gone today.
Two. Oh, because of calculus.
It's
Yeah.
dragged.
Okay, so let's come back to here. Chris told us that the derivative was going to be 6t minus 12. Okay, so I want you to write down that our acceleration is our acceleration is 6t minus 12. Okay. Now, when we talk about our relationship with function to second derivative, our second derivative is describing the concavity of the curve. I want you to remember that. Okay. So we see here that we have negative acceleration from 0 to 2. From 0 to 2, we have negative acceleration. Notice how that corresponds with the concave down portion of our curve. Okay. We have positive acceleration from 2 and on. That corresponds to the concave up portion of our curve. Okay. Now, let's go back to our velocity. Where did we determine that it was moving right? Forward infinity. And we determined that it's moving left from 0 to 4, right? Okay. So if we compare these two, okay, from 0 to 4 we have negative velocity. From 0 to 2 we have negative acceleration. So do you agree that from 0 to 2 both our velocity and acceleration is negative? Okay. And if you want to draw a number line to help you see that. We have negative and then positive acceleration. Okay, so we would say that we are speeding up from 0 to 2 because both acceleration and velocity are negative. Okay, where else would we be speeding up? I see that we have positive velocity from 4 to infinity. And I see that we have positive acceleration from 4 to infinity, don't you? So from 4 to infinity, we are also speeding up. Okay. However, from 2 to 4, I have positive acceleration, but negative velocity. So we would be slowing down from 2 to 4. Okay, so it may help to draw out these number lines so you can compare where the negatives match up, where the positives match up, and where you have that mismatch of sign. Okay. I'm going to come back to our velocity graph because I just want to remind you of some things that we talked about. Okay? If we have a velocity graph, we can still determine our acceleration. Remember, where the derivative is decreasing, then our second derivative would be negative. Where our derivative is increasing, then our second derivative would be positive. So we know that our acceleration is negative from 0 to 2 because our velocity is decreasing. And we know our acceleration is positive from 2 on because our velocity is increasing. So don't forget the relationships with derivatives and their graphs as we go through all of this. Okay, let's talk about what we would do if we have just an equation. So go ahead and write this down. Okay, reading of the graphs will be important, but also the algebra part. But if I give you an equation without the graph, we need to be able to use calculus with algebra to be able to answer all these questions. Okay, so our velocity. Okay, all we have to do is take the derivative. If we take the derivative, we're looking at 6t squared minus 42t plus 60. Okay, if we are going to analyze if our particle is moving right versus left and where, what should we know about our velocity?
Oh.
Yeah, we needed zeros, don't we? Okay, we need to know where the particle is stopped so we can determine where it's switching directions. So we need to set this velocity equal to 0. Okay, I'm going to think ahead here. We have a trinomial, but it looks like there's a GCF of, so let's factor it out. So we have t squared minus 7t plus 10. Which factors to t minus 5 times t minus 2. Okay. So we have critical points at 2 and 5. It is possible for you to get negative values for t in which our velocity would be negative. Those really aren't going to matter because we're really talking about time is 0 on. Okay? So let's throw these on a number line. Please, it is important for you to label your number line so you can keep track of which one represents velocity and which one represents acceleration. Okay? So, if we throw these on here, if I plug in a number less than 2, what kind of velocity are we going to have? What do you say? Positive. Okay, 0 is probably a pretty good number to plug in, right? If we plug in a number between 2 and 5, what kind of velocity do we have? Maybe looking here would be a nice place to look. 6 times 3 minus 5 times 3 minus 2 would be negative. And then after 5, okay, we plug in 6. 6 times 6 minus 5 times 6 minus 2, that will be a positive value. Okay, so we know that the particle is stopped at t equals 2 and t equals 5. Okay, we also know that we are moving left anywhere our velocity is negative. So this particle is moving left from 2 to 5. We also know that our particle is moving right anytime our velocity is positive. So from negative infinity to 2 and 5 to infinity. Any questions about that? I mean, it's really just unit 2 or unit 3 stuff, but we're applying it to a motion scenario. So let's keep going here. Let's go ahead and talk about the acceleration. What? Okay. Is that you that made that noise? Of course not. Okay, so our acceleration, if we come back to our velocity and go to like the nice pretty one that hasn't been factored out, let's talk about our velocity. Our acceleration. So its derivative would be 12t minus 42. Okay. All right. Now, in order to figure out the different acceleration, we need to set it equal to 0. When is 12t minus 42 equal to 0? Try that again.
We were really close.
Okay. So let's make a number line for acceleration. Notice how I'm labeling it with an A. So 7/2. We have what kind of acceleration to the left of 7/2? What? Negative. And after 7/2? Okay. So if I want to know where we are speeding up versus slowing down, I need to compare these two right here. Right? So starting at 0, we have positive velocity and negative acceleration, right? Okay. So we would be slowing down from 0 to 7/2. Okay. Nope. 0 to 2. But then at 7/2, at 2, we change to negative velocity. So from 2 up until 7/2, we have negative velocity and negative acceleration, so we would be speeding up. At 7/2, though, our acceleration changes. So from 7/2 up until 5, we have negative velocity but positive acceleration. So we are going to be slowing down from 7/2 to 5. Okay? But then at 5, we change to positive velocity. So now we match up positive velocity, positive acceleration. So from 5 and beyond, we are going to be speeding up. What do you think? Yes?
Does it matter if you use like a 0 or an infinity right there?
Like to start?
Yeah, on the slowing down one.
Preferably a 0 because I don't want negative time. And since t represents time, I don't care about the negative numbers.
Okay, so like when we did it up there for the moving left and right.
Oh, thank you for pointing that out. You're right. I got caught up in the graph of it. So yeah. Thank you for pointing that out. Okay. In your homework, there's also going to be a problem that asks you to look at a chart. There's going to be problems that ask you to look at position graphs. There's going to be problems that ask you to look at velocity graphs. And then there's going to be problems that ask you to look at equations. So really, as long as you know how position, velocity, and acceleration are related by derivatives, then you should be able to use all of your skills from Unit 3 to answer these questions. Really, the biggest interpretation piece comes from knowing what it means to have positive and negative velocity, and knowing what it means to determine speeding up versus slowing down with both velocity and acceleration combined. Okay? So I'm going to hand out two things. Actually, I'm going to hand out one, and Eli's going to hand out the other.
Of course. Did you see those questions?
Yeah, I'll have to do it. So the pink is your worksheet. Like I said, probably during Titan time, which is here in like 10 minutes, I'll post my answer key. And then Eli's handing out your last gold sheet. Okay. And every single homework assignment in this unit is a worksheet. No, this is one. This is your homework for tonight.
All of it?
Yes.
Okay.
Okay.